In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet solving one-step inequalities by multiplying or dividing. This is very similar to solving one-step equations, except now we're just dealing with inequalities. So our directions are to solve each inequality and graph its solution. Now there's one tricky part that we need to remember when we multiply or divide to solve these inequalities. If we ever multiply or divide by a -1 or any negative number for that fact, we need to remember to switch the inequality sign. So number 1 is a perfect example that we'll dive into, and I'll re-explain that concept in number 1. So we have -4m is greater than or equal to -4. Just rewriting this directly down here. Now, I need to solve this in one step by either multiplying or dividing. And I need to isolate my variable m, because once I isolate it, I'll be able to graph for it. So I'm going to divide by what it's multiplied by, that -4. And I'm going to do so on both sides of my inequality. Just like an equation, whatever we do to the left-hand side, we do to the right-hand side, and vice versa. Now notice, -4 divided by a -4 is equal to m. And -4 divided by -4 is a +1. But remember what I said at the start of this worksheet. When we divide by a negative number, we need to switch the inequality sign, which means we're going to point it the opposite way. Right now, it's greater than or equal to, so we're going to switch it to be less than or equal to. Now, there we have it. That's our inequality. We just got to graph it. So we're going to locate 1 on our number line, circle it. This is a less than or equal to, so we're going to fill it in. And m is less than or equal to 1, so that's everything to the left or 1 itself. So shading in, making sure to also shade in that arrow, because we can have values that are less than -1, like a -2, -3, -5.6, and so on. Now let's pick a point and double check that we did this correctly. And you'll see that switching it was indeed the right thing to do. So let's pick a value less than or equal to 1, let's say that 0. If we were to plug 0 in, 0 is indeed less than 1. It's to the left of 1, so it's less than 1, so that checks out. And we can also plug 0 up into our original inequality and solve. So if we were to put 0 in for m, -4 times 0 is 0, and 0 is indeed greater than or equal to -4. Let's move on to number 2. In number 2, we have n divided by 5 is less than or equal to 2, or n fifths is less than or equal to 2. So because n is divided by 5, and we need to isolate it, in order to get it all by itself, we're going to multiply by a 5. So rewriting this down here, n over 5 is less than or equal to 2. We're going to multiply both sides by 5. Because when I multiply this left-hand side by 5, 5 times n divided by 5, this 5 will cancel out with the 5, because 5 divided by 5 is 1. And 1 times n is simply n. And that's going to be less than or equal to 2 times 5, which is 10. No need to switch that inequality because I didn't divide or multiply by a positive number, so we're going to leave it as n is less than or equal to 10. Finding 10 on our number line, circling it, shading it in, and then shading everything to the left. And if you're confused on which way to shade, I'll leave a link up here to an introductory video on inequalities. So go ahead and check that out if you're still unsure of which way to shade on the number line. For now, let's continue on to number 3. For number 3, we have -4r is greater than 16. So rewriting -4r greater than 16, what are we going to do at the start? Well, we're going to divide by what r is multiplied by in order to isolate it. So since it's multiplied by a -4, we're going to divide by a -4. So -4 divided by -4 is a +1, and 1 times r is equal to that +r. 16 divided by negative 4 is a negative 4, and we divided by a negative, so what do we have to do? We have to switch this inequality sign. So as opposed to greater than, we're now going to have a less than. So r is less than negative 4 is our solution for number 3. Now we just have to graph it. Locate negative 4, circle it. We're not going to fill that circle in because r cannot be negative 4, but we're going to shade everything to the left. Let's move on to number 4. For number 4, we have n divided by 2 is less than 0. Since n is divided by 2, and I need to cancel out that 2 in order to isolate n, I'm going to multiply by it. So we're going to multiply both sides by 2. The 2 will cancel out with a 2 to give me that n is less than 0 times 2. That's going to be 0. So n is less than 0 is our solution for number 4. And graphing it, we're going to circle 0, and n are values less than 0. So not filling in 0, but shading everything to the left. Moving right along to number 5, we have x over 5 is less than or equal to negative 3/5. So in order to isolate x, what do we have to do? We're going to have to multiply by 5. So covering up our problem numbers so it doesn't get in the way when we multiply both sides by 5. So multiplying by 5, 5 will cancel out with 5, and look, over here I have a 5 in the denominator of this fraction as well, so 5 divided by 5 will be 1. So on this left hand side, 5 times x divided by 5 will be x, and that's going to be less than or equal to negative 3 divided by 5 times 5 will be negative 3 times 1, which is a negative 3. Now I didn't divide or multiply by a negative, it was a positive 5, so I'm going to leave my inequality as is. X is less than or equal to negative 3 is my solution, so I'm going to locate negative 3, circle it, shade it in, and everything to the left. For number 6, we have x over 2 is greater than or equal to 3. Because I'm dividing by a 2, in order to cancel that 2 out so that I can isolate my x, I'm going to multiply by positive 2. So 2 divided by 2 is 1. 1 times x is x, and that's greater than or equal to 3 times 2, which is 6. So x is greater than or equal to 6, locating the 6 on our number line, shading it in, and shading everything to the right. For number 7, we have 14 times v is less than or equal to 14. We're going to start by dividing both sides by 14. Dividing by 14 will leave me with v on my left-hand side of my inequality. I divided by a positive, so I don't need to switch the inequality up, and 14 divided by 14 is 1. So my solution for number 7 is that v is less than or equal to 1, meaning that v can be 1, so I'm going to circle and fill that circle in, and it's also any of the values less than 1. There we have it. V is less than or equal to 1. For number 8, we have b divided by 6 is greater than 14. So if we're dividing by 6, we need to multiply by 6 in order to get that identity of 1. Whatever we do to the left-hand side, we do to the right-hand side. So again, 6 divided by 6 is 1, which leaves us with b, and that's going to be greater than 14 times 6. So doing this quickly in our heads, talking through it, we know that 6 times 4 is 24. So we'll have a 4, carry the 2, 1 times 6 is 6, plus 2 is 8. So 84 will be our number. So b is greater than 84, which again, 84 is 14 times 6. So that's our solution. And we're going to circle 84 and shade everything to the right, but do not fill that circle in. For number 9, we have a divided by 6 is less than 13. So we're going to start by multiplying both sides by 6. 6 divided by 6 is 1, times a will be a. That was a positive 6 that I multiplied by, so my inequality stays the same way. And negative 13 times 6, what's that going to be? Well, 3 times 6 is 18, and 10 times 6 is 60. 60 plus 18 is going to be a 78, and this was all negative, so negative 78. A is less than negative 78 is our solution for number 9. Circling the negative 78 and shading everything to the left. Again, I'm just doing these numbers mentally in my head. If you need to, feel free to write it out vertically and make sure to follow through with carrying over. In number 10, n divided by 3 is greater than or equal to a negative 6. We're going to start one step, just multiply by 3. When we do so, we'll get that n is greater than or equal to negative 6 times 3. Negative times a positive is a negative, and 6 times 3 is 18. So that's going to be a negative 18. So we have n is greater than or equal to negative 18. Again, don't have to switch that because we multiplied by a positive. So, graphing this, we're going to locate negative 18, circle it, fill it in, and shade everything to the right. Number 11, negative 10x is less than negative 80. In order to isolate x, we're going to divide by what it's multiplied by, which is a negative 10. Negative 10 divided by negative 10 is a positive 1, so I get that x is, now what do? We divided by a negative, so we need to switch this inequality, so it goes from a less than to a greater than. And then negative 80 divided by negative 10 is a positive 8. So for number 11, we get as our solution that x is greater than 8. Again, we needed to flip that, so don't forget that step. Circling the 8 and then shading everything to the right. And if we want to double check, let's plug in 10 for x. If we plug in 10 for x back up in our original, negative 10 times 10, is that less than negative 80? Well, negative 10 times 10 is negative 100. And negative 100 is indeed less than a negative 80. So we know that we shaded the correct way. For number 12, k divided by 13 is less than or equal to 6. We'll start by multiplying both sides by 13. And when we do so, 13 cancels out with 13. So we get that k is less than or equal to 6 times 13. 6 times 3 is 18. And we're adding that to 6 times 10, which is 60. 18 plus 60 is a 78. So we get that k is less than or equal to 78. So we're going to locate 78 on our number line, circle it, fill it in, and shade everything to the left. Now it's time to move on to our second page. If you've stuck with me so far, don't forget to click that thumbs up button. And if you think you have multiplication and division down with inequalities, if you haven't done the addition and subtraction worksheet, I'll put a link over here. So feel free to check that video out. For now, let's continue on with this worksheet. We have 4x is greater than or equal to negative 20. So we're just going to divide by 4. Dividing by a positive, we don't need to worry about switching that inequality. So we're going to have that x is greater than or equal to negative 20 divided by a 4. Negative divided by a positive is a negative, and that's going to be a negative 5. So x is greater than or equal to negative 5. Locating, circling it, filling it in, and shading everything to the right. There we have it. X is greater than or equal to negative 5. For number 14, 60 is less than negative 10a. In this one, it's different from the other ones on the worksheet because now our variable is on our right side of our inequality. But that's okay. We're going to solve it the same way, using those same steps. We want to isolate it, so we're going to divide by what it's multiplied by, which was a negative 10. So now on our left-hand side, we'll have 60 divided by negative 10, which is a negative 6. We divide it by what? A negative. So we need to switch this inequality sign. So it goes from a less than now to a greater than. Negative 10 divided by negative 10, that's a positive 1, times a is a. So we have that -6 is greater than a. Another way we can write this, if we want our variable on our left-hand side, is to write it as a is less than -6. We can always flip the sides of our inequality, but when we flip the sides, we need to remember to also flip the sign. Because as I've stated in previous videos, think of this as an alligator or Miss Pac-Man. They always want to eat that larger value. So -6 is greater than a. When we switch that inequality, we still want that Pac-Man or that alligator to be eating that -6 because -6 still represents those greater values. So just as long as our inequality is facing the correct way, we can easily switch our sides. So a is less than -6. That means I'm going to find -6 and shade everything to the left. For number 15, 8 is greater than 8n. Again, our variable is on the right-hand side, but that's okay. We're going to divide by an 8 at the start. 8 divided by 8 is 1, and 8 divided by 8 is 1. So we're going to get that 1 is greater than n. Now, in order to read this with our variable on our left-hand side, let's go ahead and switch those sides. So as opposed to 1 is greater than n, I'm going to have the n is less than 1. These mean the same exact thing. 1 is that larger value, so I'm going to need to shade to the left. So n is less than 1, locating 1 on our number line, circling it, and shading everything to the left. In number 16, we get that 0 is greater than or equal to -2p. What I'm going to do is divide by a -2 at the start. 0 divided by -2 is 0, and I divided by a negative, so I need to switch my inequality. So it goes from a greater than or equal to a less than or equal to. So -2 divided by -2 is now a +1. Multiply that by p, we just get p. So we have 0 is less than or equal to p, or we could write this as p is greater than or equal to 0. 0 is that smaller value because we want to eat the larger value of p. Switching those sides, we still want to eat that larger value of p. So p is greater than or equal to 0. We're going to circle 0, shade it in, and p is everything to the right. P is greater than or equal to 0. For problem number 17, we have that 24 is greater than or equal to -4n. We're going to divide both sides by that -4. 24 divided by -4 is a -6. We divided by a negative, that means we're switching our inequality. So it goes from greater than or equal to a less than or equal to. And -4n divided by -4 is a +n. So we get that -6 is less than or equal to n, meaning that that value of -6 is smaller than all of our n values, or it's in itself. So we're going to be shading to the right. Again, we can rewrite this as n is greater than or equal to -6. So there we have it. That's our solution in number 17. And number 18, 4x is less than or equal to 40. Simply divide by a 4, and we get that x is less than or equal to 10. No need to switch our inequality, and no need to flip it around since we have that variable on the left-hand side. Although flipping it is just a matter of preference anyway, but we have that x is less than or equal to 10, so I'm going to circle that 10, shade it in, and shade everything to the left. X is less than or equal to 10. For 19, we have that -10 is less than r over 8. So let's start by multiplying by 8. If we start by multiplying by 8, in one step, we can isolate our variable r. So we get that 8 times -10 is a -80, and that is less than r. We multiply by a positive, so no need to switch that inequality. However, I can rewrite it if I choose, so I'll rewrite it as r is greater than -80. This helps me remember that I need to shade to the right because r are all those values that are bigger than that -80. So circling negative 80, but I'm not shading that circle in, I'm just shading everything to the right. R is greater than negative 80. For number 20, we're going to have m over 3 is less than or equal to 5. When I multiply by a positive 3 on both sides of my inequality, I'll get that m is less than or equal to 15. That's my solution for number 20. So I'm going to locate 15, circle it, shade it in, and shade everything to the left because m is less than or equal to 15. For number 21, negative 2 is greater than or equal to n over 3. Multiplying both sides by 3, we'll get that negative 6 is greater than or equal to n. Or I can rewrite this as n is less than or equal to negative 6. Either way is perfectly fine. So what we're going to do, circle negative 6, shade it in, and shade everything to the left. 22, we have 7/3 is less than or equal to p over 3. It's nice that we have a 3 in both our denominators because when we multiply by 3 on both sides, we'll cancel out each of them. So multiplying by 3 on the right and left-hand side will give us that 7 is less than or equal to p. I can rewrite this if I choose with my variable on that left-hand side of my inequality. So it's going to be p is greater than or equal to 7. Locating 7, circling it, shading it in, and p represents values that are greater than or equal to, so that's shading to the right. For number 23, we have that b over 2 is less than 7. So in order to isolate our variable b, we need to multiply by what it's divided by. So that's going to be multiplying by 2. And we need to do so to both sides of our inequality. So 2b over 2 is equal to b, and that's going to be less than 7 times 2, which is 14. So b is less than 14 is our solution. So circle 14 and shade everything to the left. In number 24, negative 12 is less than 3x. What I'm going to do just to mix it up is I'm going to rewrite this, switching what side my variable is on at the very start. So I'm going to write that 3x is greater than a negative 12. Again, all I did was switch which sides my variable is on. So when I flip my sides, I need to make sure that my inequality is facing the correct way. So eating that larger value of 3x, again, it's eating that larger value of 3x. Now, one step, I'll divide both sides by 3 to give me that x is greater than a negative 4. Locating negative 4, circling it, and then shading everything to the right. Here we go, some fun with larger numbers. We're going to have 42 is greater than x over 16. Even though these numbers are bigger than the previous ones we've worked with, we go through the same steps. We're going to multiply by 16 in order to isolate our variable x. So let's go ahead and figure out this math. What I'm going to do is I'm going to write it vertically and we'll walk through it together. So we have 42 times 16. Starting over here, 2 times 6 is 12. We'll write the 2, carry the 1. 4 times 6 is 24, plus 1 is going to be 25. So that's 252. Now, we've already taken care of the 6, so we're going to write a placeholder 0. Now let's go through. 1 times 2 is 2, and 4 times 1 is 4. So we have 252, and we're going to add that to 420. 2 plus 0 is 2, 5 plus 2 is 7, 2 plus 4 is 6. So 672 is what we get when we multiply 42 by 16. Now back to our inequality, 16 times 42 we got was 672, and that's greater than x. We could also write this as x is less than 672. So now we're going to just simply graph it. Locate 672, circle it, and shade everything to the left. Now, onto the last problem for this worksheet, number 26. Get ready to work with some larger numbers again. So we have v divided by 29 is greater than or equal to a negative 35. All we have to do in one step is just multiply by 29. Doing so, we'll get v on our left-hand side of our inequality is greater than or equal to negative 35 times 29. I know that a negative times a positive is going to be a negative, so I'll write that now. Again, let's do this out vertically. 35 times 29. 5 times 9 is 45, so we'll write our 5 and carry our 4. 9 times 3 is 27, plus 4 is going to give us a 31. Now, we'll put our placeholder 0. 5 times 2 is 10, another 0, carry the 1. 3 times 2 is 6, plus 1 is 7. So we have 315 plus 700, which equals 1,015. So 1,015, but remember, that's a negative 1,015 because a negative times a positive is a negative. So there we have it. V is greater than or equal to negative 1,015. We're going to find that on our number line, which occurs between negative 1,014 and negative 1,016. It's going to be this tick mark here. We're going to circle it, shade it in, and then shade all the values to the right. And there we have it. That wraps up this worksheet on solving one-step inequalities by multiplying or dividing. If you want more worksheets dealing with inequalities, I'll link those over here. If you have any questions, please feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as we can. And as always, don't forget to like, subscribe, and share. Happy learning!